Hello, welcome to part 2 of our video on decisions. I'm Sarah again, and we're going to start back up with Steven's video. He's going to go over the last 2 parts of his 5-part video, which are, let's see if I remember it, dilemmas and decisions. So he's going to take what he did. He walked through this idea and that idea of what he might do moving forward, and now he's going to consider both of those and end up making a decision. Let's see what happens. Let's go.
We're back, but it's not full circle. Before, I was choosing between abstract choices, COVID-19 and faster pipelines. But by trying to imagine, like a chess player, what things would be like if I chose one path or the other, I now find myself facing a different dilemma. The choice now is between starting a value funnel or converting project folders into shortcut files. Ideally, I would now calculate the cost and value of each choice. I think this might take me 1 hour of coding and website design. That's the cost. But the value, it's harder for me to estimate because it depends on the actions of others, which are hard to predict. I think this would be a one-time investment of several hours, maybe 6, because I hadn't worked with shortcut XML files until yesterday. But that would have to be spread out over several days, and every day things are getting worse. So the cost isn't as clear as it seems.
Before we get to the last part, let's just talk about how Steven evaluated those 2 decisions. I don't know about you, but I'm used to doing pros and cons list. This kind of looked like a pros and cons list, except he said something different, which was cost and value, or if we were to match them, value and cost. Value might be future time saved or people helped or money earned, whereas cost are usually time spent or money spent. All right, let's check out the last part of this video here and then move on to do some cost and benefit ourselves as we go through a coding process, do this cost value analysis.
I wish math could just come to the rescue here. But sadly, in design, sometimes the problems worth working on are the messy ones. The ones where the path forward isn't clear. The ones where half of solving the problem is just figuring out what the problem is. In a traditional engineering education, people get really good at solving problems. The more clearly defined a problem is, the more most engineers I know like it. Heck, I'm the same way. Maybe everyone is. Clarity and simplicity are beautiful things. My assignment to students would be every day, wake up and ask yourself, what is something I could do to provide value to the world today? And then also ask yourself, what is something I could do to provide value to myself today? Then try to use paper to make both of those things as clear as you possibly can. Then make a decision. For me, I'm gonna sleep on it.
All right. I just want to bring a point to one thing that Steven said there, which is half of solving a problem is figuring out what the problem is. This is something that's typically ignored in traditional problem-solving discussions, but I think is inherent in coding because of debugging. When we find a bug in our program, oftentimes most of our time is spent figuring out what is causing that bug? What is the problem? So in order to solve the problem, you need to figure out what the problem is. And Steven's exactly right. That's the messy part. That's the frustrating part because it's not exactly clear. Let's move on to do a little bit of coding. What we're going to do today is we're going to use WeScheme, an online platform. The link to it is below. If you want to code along with me, I encourage you to. And we're going to make some decisions on our own. We're going to look at the value and the cost of different ways of coding something and make a decision. So let's go ahead and take a look here. So what I have right here is some code. I'm just going to make a circle above a rectangle. And if I run it, yep, there's a tree. Say my project is I want to make a forest of trees. I've got a couple different options and decisions to move forward. Option A is copy and paste. If you've done any coding, you probably already know that this is not the right choice moving forward, but let's just experiment for why. There we go. So let's say that's my starting point for my forest. This is option A, copying and pasting. For those of you who watched Jason's last video, you know copy and paste breaks one of the number one rules of coding, which is dry. Don't repeat yourself. So I'm repeating myself not only 1, 2, 3 times here, but also I've kind of repeated this chunk of code with this chunk of code. So the reason not to repeat yourself is because of the cost. So let's first look at the value. Value is I got what I wanted, right? This forest. It's not exactly a very interesting forest. The cost is this dry, this I've repeated myself. Why is repeating myself a problem? Because when I repeat, I'm creating something we call technical debt. So my cost here is technical debt. It means that when I come back to this, it's going to cost me time. Why is it going to cost me time? Because say I want to change something. Say I want to change the color of all the trees. That's going to take a while. That I have to do with every single one option there. So more lines of code tends to be more brain work. So the option B would be to define a constant. That looks something like this. Now that I've defined my constant, I can use that in place of every place that I wrote this above, like this. I went back to the darker green. I think it looks more like a forest. So here, I've got the exact same code again. What's the value? Looks like I want it to right now. Still not a super variant forest, but it's there. What was the cost? Did take me a little bit more time to think about this definition here, but look at all the time I saved when I write it. And if I were to want to write another forest that looks slightly different, would save me a lot of time. If I want to make a change, I want a forest that's in the middle of fall. Boom. Easy to change, make a change across everything. Later down the road, say I want a different tree. I'm going to have to write a whole different constant and use it again later. So that's time in the future that would be a cost. So let's look at option C, which would be defining a function. The function means that I can change it as opposed to a constant that looks one way. I can pass in arguments and parameters to maybe customize what my tree looks like. Let's walk through what that might look like. All right, so I have my definition here. When I run this, nothing happens. But if I wanted to make a tree that looked exactly like the one before, I could call my tree function. Leaf size was 30, leaf color was dark green, and the height was 50. That makes a tree that looks exactly the same as before. However, say I want a totally different tree. Look how easy this is to make. Boom, I got 2 different trees. So I can make a forest that looks like this. Here's a quick trick. I don't like how this is lining up, so I'm going to use something called beside a line and put in bottom. We can see that's going to line it all up by the bottom. Let's add some more trees. All right, let's take a look there. So now I have, what's the value of this? This forest looks a lot more interesting than the other forest did before. We've got lots of different colors, different heights, different colors. That's value. That's a lot cleaner. I can make changes really fast, super fast to my code. The cost? This did take me more time to write. I had to think about what do I want to have here. I had to walk through this, potential for bugs in that process. But think about how much time I've saved in the future as well. Doing my value cost analysis, of course, rather than imagining it and I walked through all of it, I clearly can find that this is probably the highest value for the lowest cost that I have. So this brings us to the eternal coding question, or what I think of as the eternal coding question. Will I save more time if I write something to do this for me, or if I do it by hand? So you have to think about all the time that it'll spend writing code to do this, if I write it as a function or whatever that looks like, versus the time spent if you don't write that function. You don't spend that time up front, but you will spend more time over a longer period of time, writing that code again, even maybe going back and fixing things and moving forward. So as a coder, we're constantly weighing this decision. So it's good to practice that forward thinking and going, well, how many times do I do this? How many times do I think I'm going to do this? How well do I know how to code this? And it's not a perfect science, and oftentimes we're wrong. We run into something we didn't expect. It takes us longer, but that's part of being a coder. And if you learn new things, and then maybe the thing that you learn as you do that helps you out in the future and saves you more time. You never know. All right, well, thank you for joining us today. If you are watching on YouTube, that's it. Udemy, go on to our assignments there, and I hope you all staying safe, and we'll see you next time. Bye.